Hi guys, we are on to lesson 5, exponents. Okay, I know you've seen this and we've you've seen it a little bit during our math minute warm-ups. Now we get to learn more about it. So today you're going to learn that x cubed, or x to the power of 3, is the same as x times x times x. That understand that a base number, which is this number right here, can be represented with a positive whole number, positive fraction, or positive decimal, and that for any number a to the m is defined as the product of m factors of a. And the number a is the base, and m is called the exponent or power of a. It'll make more sense later, I promise you. As you evaluate these expressions, pay attention to how you arrived your answers. So we have a bunch of 4s here. How do you evaluate or answer that? Okay. How did you evaluate or solve each expression? Take the time that you need to do that. Did you add or did you multiply? So you look at these numbers, and do you automatically say, okay, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, okay, plus 4, 24? Or did you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so 4 times 10 equals 40? How did you do it? Which way is faster, adding each number or multiplying? Okay. If you're like me, you're going to say multiplying. Multiplication is the faster way to add numbers when the add-ins, or the numbers you are adding, are the same. When you add 5 groups of 10, we use an abbreviation and a different notation called multiplication, right? So instead of 10 plus 10 plus 10 plus 10 plus 10, we say 5 times 10. Do you think there might be a more efficient way to represent the repeated multiplication of the same factor? So let's use this as an example. Remember our 5 tens that we're multiplying? Okay. The faster way to represent this would be 10 to the power of 5. Okay. We call it to the power of 5 because it is raised and it's little, and that means that that's our exponent. So we call it 10 to the power of 5. Okay. And it is written, okay, fine. They call it a superscript. Okay, little 5 we write is called an exponent and is written as a superscript. We're careful about how we write the superscript because it reduces the chance that a reader will read 10 to the power of 5 as 105. So you can see how that could happen, right? Write each expression in exponential form. So if you want to pause this video, pause it so you can do this. All right, so how many 5s do you see? I see 1, 2, 3, 4, 5. So that means that is 5 to the power of 5. How about this 2? How many 2s do you see? So I see 1, 2, 3, 4. And that would make it 2 to the power of 4. So write expression in expanded form. These are still examples on page 14 to 15. So I have 8 cubed. Okay, when we have a 3 up here, the exponent is 3, that's called cubed, and we'll get into that a little bit more, so how that happens. Now, how many do you see? 8 times 8 times 8, right? So 3, it says 8 cubed, so that means we're multiplying 8 3 times. Your turn to do 10 to the power of 6. How many 10s do you see? How many 10s does our superscript tell us to multiply? Okay, tells us to multiply it 6 times. Does it work for the same for the G? Okay, how many G's does our superscript tell us to multiply the G's? It does. It tells us to multiply it 3 times. G times G times G, and it works the same way as it would the numbers. Now we'll go back to examples 1 through 4. Remember that we saw that, and use a calculator to evaluate the expression. So we had 5 times, 5 to the power of 5, and that equals 3,125. So pause right here and solve for the rest. I know that there are some that you can do by hand. If you can do it by hand or in your head, that's fine. Let's go on. 2 times 2 times 2 times 2 is 2 to the 4th power. Okay, and so that is 16. Because 2 times 2 is 4, times 2 is 8, 8 times 2 is 2, 8 times 2 is 16. 8 cubed, once again, 8 times 8 times 8, and that equals 512. 10 to the power of 6. I'm going to show you a little trick here in a little bit. So we had 10 times 10 times 10 times 10 times 10 times 10. Here's a little trick about multiplying tens. Okay, right? Any tens, 100s. See how many zeros we have? 1, 2, 3, 4, 5, 6. That's exactly the same number of zeros that we're going to have in our product. Remember that we're multiplying, your answer is a product. 1, 2, 3, 4, 5, 6. Just a little trick. That's 1 million. So what is the difference between 3g and g cubed, or g to the power of 3? 3g, there's a mistake right there. That should mean g times g times g times g times g times g. So these should be multiplication symbols. Sorry, guys. Must have been a long evening that time. So, oh, sorry. Okay, step back. 3g, that is 3g. That just means 3 times g. So that's g plus g plus g. Okay, we multiply g 3 times. It's a long evening tonight. G cubed is g times g times g. That is the difference between those two. So remember, the base number can also be written in decimal or fraction form. So try examples 6, 7, and 8. Use a calculator to evaluate your expressions. And I hope you're not as tired as I am. Okay, so lesson 5, lesson summary, which is on page S18. Exponential notation for whole number exponents. Let m be a non-zero whole number. Remember that was the base. Sorry, that's our exponent. For any number a, the expression a to the m is a product of m factors of a. That means a to the m, you're going to multiply a however many times m tells you to. Okay, this little guy tells you to do that. The number a is called the base, and m is called the exponent or power of a. So when m is 1, okay, this is something important that we did not talk about earlier. When m is 1, the product of one factor of a to the m just means a. So that means a to the power of 1 equals a. Raising any non-zero number to a to the power of 0 is defined to be 1. So if you have an a to the power of 0, that just equals 1 for all a that does not equal 0. Okay? So a should not equal 0, but your exponent can. And when it does, that just tells you 1. All right, so your next steps. Lesson 5, you're doing your examples. Remember, I told you to do the examples and your exercises. When you're done, do the exit ticket. Write your name on the board, guys, if you need help. And I already told you what you're doing. Solving examples and exercises. Okay? Looking forward to seeing you guys lesson 6. Bye.